Okay, here we go. Section 5.6. Let's just kind of review quickly about section 5.5. From section 5.5, do we remember how to multiply two binomials together here? Anybody remember how we did this last week, section 5.5? How would we multiply these binomials? Well, we had a nifty little algorithm. Anybody remember the name of that algorithm?
The FOIL method.
Okay. And the FOIL method had us beginning by multiplying our first terms together. So we would take x times x. That's the product of our first terms. Plus, then we'll multiply our outer terms together, x times 3. Then we multiply our inner terms together. And then we multiply our last terms together. And we get this word FOIL here. X times x is x to the first power times x to the first power is x to the 1 plus 1 power, or x to the second power. Now 3x and 5x are like terms, they should be combined. And what is 3x plus 5x? Well, they would combine to give us 5x. 3x plus 2x is 5x. And 2 times 3 here is going to be 6. So this was the FOIL method of multiplying two binomials together. We discovered last week. Okay, that's probably one of the most popular ways of multiplying binomials together. Not the only way, but probably, like I said, the more popular way. All right. And then I think we closed out the section by looking at how to multiply like maybe 3, or excuse me, how to multiply like a binomial by like a trinomial or something like that. All right. Now, unlike multiplying two binomials together where we have our FOIL method, we don't really have a nifty little name for multiplying a binomial by a trinomial or a 4-term polynomial, etc. The bottom line is when you do multiply polynomials together, you just got to make sure that each term of your first polynomial gets multiplied by each term of the second polynomial. So x has to get multiplied by this x, and then by 3. 2 has to get multiplied by x, and then by 3. Same thing for a binomial times multiplied by a trinomial. We got to make sure that each of these 2 terms in the first polynomial get multiplied by each of the 3 terms of our second polynomial. So we'll take x times 7x squared plus, and we'll take x and multiply it by negative 5x plus, then we'll take x and multiply it by 10. Now we're done with the x, so we abandon the x and move to the 2. And then we take the 2 and multiply it by 7x squared. Plus, we'll take the 2 and multiply it by negative 5x. Plus, finally, we take the 2 and multiply it by the 10 way over here. Okay. All right, now what's x to the first power times 7x squared? That's going to multiply together to give us 7x to the third power plus x multiplied by a negative 5x is going to be negative, it'll be negative 5x what squared plus 10 times x is 10x. 2 multiplied by 7x is going to be 14x squared. And 2 multiplied by negative 5x will be plus a negative 10x. And 2 multiplied by 10 will be a 20 out here. Now, what we do is we want to combine any like terms that need to be combined. 7x cubed has nothing to combine with. Negative 5x squared can be combined with 14x squared. What's negative 5 plus 14? What would that give us? Negative 5 plus 14.
7x.
Negative 5 plus 14 is 7. Let's see. Negative 5 plus 14.
It's 9.
9. We'll say plus 9x squared. I always put a little light slash through these. That gives me a visual cue that I've dealt with these. 10x plus a negative 10x. What happens to the x's? It's like they add up to 0x, don't they? They cancel out. We'll have to put plus 20 here. All right, so that would be the product of this binomial and this trinomial. It happens to be this. And notice our answers are always written in descending order, where the degree of each term decreases from left to right. Okay, now, so that was section 5.5 in a nutshell. We introduced ourselves to multiplying polynomials together, especially binomials and binomial and trinomial, things like that. So that was the order of business in section 5.5. Well, what we did in section 5.5 can, in large part, can kind of help us in 5.6 too. But in 5.6, ladies and gentlemen, they're going to warm us up to some important patterns that are going to become very important when we start learning how to factor polynomials in chapter 6. Factoring is kind of like the reverse FOIL method, if you will, where you take a polynomial and you write it in terms of its factors. And factoring polynomials, although more challenging than multiplying polynomials together, is probably the most important skill that you can attain out of this math course. A lot of you will be going onwards to maybe take a little bit more math, in which case your factoring skills are going to be very important in higher level math courses. So that's chapter 6. Okay. So in section 5.6, we are going to look at what are called special products. It's entitled special products. Okay. Now, the first product that we're going to look at is what happens when we square a binomial. Like when you have like a plus b and you square the binomial. This is the first special product that we run into in this section. And when you square a binomial, what does that mean to do? Well, what it means to do is to take the binomial and multiply it by itself. Okay, as that's true with anything that is squared. Now, if we used a FOIL algorithm and drag this out the long way, we'll have a times a. A times a is a squared. All right. We're going to take a times b, which is plus ab, and b times a is ba. plus b times b is b squared. So again, I multiply my first terms together, outer terms together, inner terms together, and last terms together. Now, these two middle terms, what do you notice about them? What do you notice about those middle terms?
They're the reverse.
Well, the factors are in reverse order, but do you agree that if I have 2 times 3, that's the same thing as 3 times 2?
Yeah.
So it doesn't matter in what order you multiply these together. So my point is, this BA term is really the same thing as another AB term. Just switching these two factors, same thing. So what's 1AB plus 1AB is these are like terms. 1AB plus 1AB nets us with 2AB. All right, and so, ladies and gentlemen, this is the key here. Your author, believe it or not, wants you to memorize this pattern here. This is an important pattern to commit to memory. Instead of having to go through all this long, laborious multiplication here, if we can remember this pattern, it's going to help our ability to square binomials. Notice when we square a binomial, it's the square of the first term plus 2 times the first term times the second term plus the square of the last term. In a similar fashion, so this is a pattern that you probably want to commit to memory. That's what I'm saying, ladies and gentlemen. So we want to memorize this. All right, memorize. All right. You'll see that it pays off handsome dividends later on, not only in this course, but also if you go into intermediate algebra and maybe college algebra. Now, if I was to take a minus b and square it, this would be saying, you know, to take a minus b and multiply it by itself. And again, you know, if we want to drag this out the long way, we would FOIL this out. So a times a is a squared. A multiplied by negative b is minus ab. Multiplying the inner terms together, negative b times a is minus ba. Multiplying the last terms together, what's a negative b multiplied by a negative b? That would be plus what? B squared. Notice these two middle terms are like terms. They really are the same. So we would have a squared minus 2ab plus b squared. And so there, ladies and gentlemen, when you square a binomial of the form of a minus b, the square of that binomial is going to look like this. So this is also something that you want to memorize. Okay. Memorize this also. So these are called special products here. The special products that are boxed in here. This instructs us how we are to square a binomial where we have the sum of terms. And this is to instruct us how we square a binomial where we have the difference between terms. Notice these patterns are pretty much identical to each other. What's the only difference between these patterns here, these products?
One addition and one subtraction.
Yeah, this was addition, this was the minus. Notice it's easy to remember here, whatever this sign is here, that sign carries over in between the first two terms. So if this is a plus, this is a plus, this is a minus, that's a minus. The last term is always a plus, okay? All right, so this is the first special product that is being touted in section 5.5. And this special product here, ladies and gentlemen, is supposed to speed up our ability to square binomials. All right, that's the point of this, these special products here. So let's see if we can, you know, employ these special products here to help us more efficiently square binomials instead of multiplying it all out, you know, using the FOIL method, which does consume quite a bit of time. Okay, so we got our special products here. I have to get rid of this page, but just because we get rid of this page, just try not to forget these special products. All right. Okay, let's see how it can help. These special products can help us. Suppose we want to simplify this expression here. What if I have 2x minus 3y and we want to square this? Okay. Now, the long way of doing this problem is to FOIL this out, but that really is not the intention in section 5.5. The intention is to tap into one of these products here, special products, and have memorized these special products here. So which product would I use? Would I use the minus or the plus version? Minus or plus?
Minus.
So we're going to use this minus version here, the special product, and we will notice that the square of the difference of terms of a binomial expands out into this. All right, so below this special product, below this problem rather, I'm going to put the special product here that we're going to use. A minus B squared, which if we have this memorized would be equal to A squared, all right, minus 2AB plus B squared. All we got to do is follow along here now. So what would be my A term here? As far as my problem is concerned, my A is really like a what term? My A is really like a 2x, okay? So my A is like 2x. And what's my B term? B is like a what? B is like equal to what, 3y? Okay. So all we have to do is, if we have this pattern memorized, it will speed up our ability to square this binomial. We drop in 2x in place of A here. So it's going to be 2x that drops in here, minus 2 times A times B. So minus 2 times A times B. A being 2x, B being 3y, plus B squared. But what's B? B is 3y. So we square 3y. So this would be the product or the expansion of 2x minus 3y squared there. Everybody see how we fit it into the pattern? So anyways, what we got is we got this. Now to simplify this, we really should clean this up. We don't want to leave this looking this way. So what's 2x squared? When I square this monomial, what's 2 squared? 2 squared. What would 2 squared be?
Would it be 4x squared?
Yeah, so this is going to be 4x squared minus 2 times 2x is 4x, and 4x multiplied by 3y would be 12xy plus, what's 3y squared? What does this simplify to? 3y times 3y.
9y squared.
See that? So ladies and gentlemen, if we can memorize this pattern here, it will enable us to speed up our ability to square a binomial instead of dragging us out the long way using the FOIL algorithm. That's the intention of these special products in section 5.6. That's what your author has in mind, that we maybe begin to memorize these special products here. So these 2 special products inside the boxes, you might want to just kind of commit to memory here, okay? Throw them away in the memory banks. All right, called special products. All right, let's try another one here. Let's try to simplify. How about one that's even nastier than that? How about like 5x squared plus 2y cubed, and we want to square this binomial. Now, the long way of doing this, like I said, is to drag this out using the FOIL algorithm, which, you know, you could do that, but the point is to try to employ these patterns. So notice we have the sum of 2 terms of a binomial that's being squared. So therefore, we're going to tap into this, this particular pattern here, which if we have this memorized would be a squared plus 2 times a times b plus b squared. Notice our A is really a 5x squared. Notice A is 5x squared. And our B term is like a 2y cubed. Therefore, wherever we see an A, we drop in a 5x squared here and here. And wherever we see a B, we drop in 2y cubed here and here. So we're going to follow along. So we're going to have A squared, which means we're going to have 5x squared squared plus 2 times A being 5x squared, times B being 2y cubed, plus B squared, where B is 2y cubed. All right, so what are we going to get when we simplify this now? Well, what's 5x squared squared? What's 5 squared? 25, and x squared squared is x to the 2 times 2 power x to the 4th power. So 5x squared squared is going to be 25x to the 4th. 2 times 5x squared is 10x squared, and 10x squared multiplied by 2y cubed. This is going to be 10x squared multiplied by 2y cubed is going to net us 20 plus 20x squared y cubed. 2y cubed squared is going to be 2 times 2 is 4, and y cubed squared is y to the 3 times 2 power y to the 6th, and we're done. You see that, ladies and gentlemen? We're done. We got our answer. Now, if you were to FOIL this out, I do believe this would take a little bit more time. Do you agree? Do you think that would take more time to FOIL it out the long way?
Yeah.
Yes, and more paper.
It's going to take not only more time, it's going to take more paper. And so the key is, again, I cannot emphasize enough, ladies and gentlemen, the key is we want to start to warm up to using these patterns, these special products, they call them, okay? If we can just memorize these special products, it's going to speed up our ability to square binomials. So that's the whole intention of these special patterns, is to try to make our life a little easier. So again, it comes down to maybe, hopefully you can maybe memorize, commit these patterns to memory there. All righty. Okay, I'm going to give you some problems to do now. We're going to call this classwork 1, and I want you to maybe, utilize one of these patterns to help us to expedite our ability to square some binomials, okay? So we'll call this, any questions on this first of all? Any questions at all? All right, so we'll call this classwork number 1. Today is the 15th day of November. It is, I believe, the first day of what, firearm deer season. Is that correct? Yeah, you want to be careful on the roads, especially at nighttime, because deer are on the move, ladies and gentlemen, during hunting season. 2 years ago, around this time of the year, I was coming back on 23 northbound, about 9 p.m. at night. I was driving the speed limit, about 70 miles per hour. And within 1 second, a deer bolted out of the median of the expressway and slammed head on right into my driver's side headlight. It happened within 1 second. I had no time to react whatsoever. I just kept driving. The deer hit my front driver's side headlight and caromed off the side of my van, and I don't know what happened to the deer. I didn't stop or go back. There were no cars or vehicles around me. That's the good news. But that scared the living daylights out of me. It happened within 1 second. That's about it. 1 second. Did a lot of damage in front of my vehicle. Had to take it to a collision place, and they fixed it. But I tell you, that was quite an experience. So be careful when you drive at night this time of the year. Deer are on the move. If you see one deer crossing the road, slow down, because usually there's more behind the deer. They usually come in packs, okay? So just be careful. All right, we'll call this classwork number 1, ladies and gentlemen. I want you to try to simplify all these problems here. Hopefully you can make use of any of the patterns, the 2 patterns that I showed you. Problem number one, I want you to try to take negative 3x squared plus 5y cubed, and I want you to try to square that. Number two, I want you to try to take 2xy minus 3y squared. Try to square that using a pattern. Number three, 5x cubed minus 4y to the fifth. Square that. And one last problem here. Let's go with negative x squared y plus 10 x 10. Tell you what, let's use a different variable here in the end. Let's put like the variable like z in here or something. Let's just try something more interesting here. So we'll put the variable z in here. So we'll put the variable z in there. That'll be 10z. And that will be cubed. And let's try to square this. I'm going to give you time to work on these. Take your time, do a good job, ladies and gentlemen. Making use of the patterns that we've seen. See if you can, multiply those out here. And please try to use the patterns. That's the point here. The point is not to FOIL these out. The point here, ladies and gentlemen, is to try to make use of, the patterns that we've seen. One of those two patterns here. Okay. All right. So I'll give you some time to work on these to see if we can accomplish doing this here. Okay, anybody need more time on these? Anybody
Yes,
wanna?
please.
Oh, okay, all right, go ahead.
Thank you, I'm ready.
Okay, we ready? All right, anybody get the first one? Want to read off the answer? Tell you what, let me just put these answers up here. Do any of these look like yours?
My first two. My first two do.
Okay, that's good. Well, at least you got the first two correct.
I got that. Well, the first three correct.
All right, first three.
I got the first two.
Okay. Well, at least you're on the right track. Let's see, this third one here is we got to follow the a minus b squared here because we got a minus b. And so that's going to be a minus b times a squared plus 2ab. Wait a minute, what am I thinking of?
That's what I did.
No. It's going to be a squared minus 2ab. I was thinking of factoring. I'm ahead of myself. There we go, like that. So your A is really a what, 5x cubed. So wherever you see an A, you got to put a 5x cubed. You got 5x cubed. And where you see a B, your B is really 4y to the fifth. So you got to put 4y to the fifth in here for B. And so what you're going to have here is you square this, you'll have 25x to the sixth. Negative 2 times 5 is negative 10. Negative 10 times 4 is minus 40. X cubed y to the fifth. And this is going to be 16y to the 10th. 16y to the 10th. That's how that would work out there. Okay. Did anybody get the last one correct here? Anybody get the last one correct?
I did.
Somebody did. All right, that's great. All right. So, I mean, the point of this is, I mean, to start using these patterns here, the fact that when you got a plus b squared, maybe we can hopefully think of it as being a squared plus 2ab plus b squared. And when you got a minus b squared, hopefully we can think of that as being like a squared minus 2ab plus b squared. Okay, so these patterns here, like I said, ladies and gentlemen, are intended to kind of speed up our ability to square binomials. Okay, that's the point of using those patterns there. All right, so these are two special patterns in section 5.6, and there are a couple of other special patterns that in fact, there's one other main special pattern that we want to become accustomed to, but these are two, like I said, that you, it would be probably wise just to memorize these. It's going to help our cause later on when we start going in reverse direction in chapter 6. When given a polynomial, we're going to be asked to factor it back out into its factors. And that's much more challenging than what we're doing in chapter 5 here. So probably wise to memorize those patterns there. Okay. All right. Well, so let's see here. So the other special pattern or special product that we need to concern ourselves with in this section is this one here. When we multiply binomials together, where the difference between the binomials is just the sign in between the terms. So this is a plus sign and this is a minus sign, or if you had the minus sign here and a plus sign here, it doesn't matter if these signs are switched. These binomials are called conjugates of each other. I'm going to write that word down. This is an important word. Anytime you have two binomials that differ only by the signs in between the terms, they're called conjugate binomials. And conjugates become more important, as you will find out when you get into intermediate algebra, math 120, and or college algebra, math 130 down the road. These are called conjugates of each other. And ladies and gentlemen, let's work this out the long way here. If we were to FOIL this out, let's see what would happen. Okay, so we're going to FOIL this out and see what happens. So we take the product of the first terms, a times a. And what is a multiplied by a? A times a gives us
A
B
squared.
squared.
a squared. Multiply the outer terms together, a times a multiplied by a negative 1b. A multiplied by negative b is minus ab. Multiply the inner terms together, b times a is plus ba. Multiply the last terms together, b times a negative b. B multiplied by a negative b is a minus b squared. Now, AB and BA is the same thing as AB. So if you just basically spin these factors around, you still have the same product. So therefore we have A squared minus AB plus AB minus B squared. And what do you notice happens between the two middle terms here?
They cancel out.
So these two middle terms basically sum up to 0 AB, don't they? Negative 1 AB plus positive 1 AB. Technically, those add up to 0 AB. And 0 times anything is just 0. So we don't even report this. So we have A squared minus B squared. And so there we have it, ladies and gentlemen, another very special product here that we want to commit to memory. Anytime you multiply two binomials together that are conjugates of each other, you're always going to get the difference between the squares of the terms. So this is another very important product to memorize. Right there. And you will discover that when we get into chapter 6, that having memorized this pattern is going to help immensely in factoring what is called the difference between perfect squares. Okay, the difference between two squares would factor into this. So we want to memorize this pattern here, very important. So that's the other special product or pattern that your author really wants you to try to memorize in section 5.6 here. And like I said, the sooner that we do memorize this special pattern, the better off our lives are going to be, mathematically speaking. Okay. So it's this last pattern here that ultimately is going to enable us to close the door on section 5.6 here this afternoon. Okay. All right, so let's see if we can try a couple of these out using our brand new pattern that we have just established. It basically says, again, when you multiply conjugate binomials together, their product is always going to be the difference between the square of the first term and the square of the last term. Notice that that's the way it works there. Okay. All right. So armed with that pattern now, maybe we can try a couple of problems here. All right, so let's just try a couple. So we're going to try to multiply these out. We will try, first of all, let's just go with x plus 2. We're going to try to multiply that by x minus 2. Okay, so x plus 2 multiplied by x minus 2. All right. So when we multiply these conjugate binomials together here, we notice that they are indeed conjugates of each other. This is a plus, this is a minus. Other than that, they're identical to each other. And according to our pattern, we're just going to follow along here. So we have a plus b in general times a minus b. And according to the pattern we established, this is going to be equal to a squared minus b squared, where our a is really an x here. Notice our a is really an x and our b is really just a 2. So a is x and our b is 2. All we have to do, ladies and gentlemen, is multiply. Instead of multiplying these out, we're foiling this out, which you could do. I mean, you can always use your FOIL, algorithm to multiply these out. There's nothing that says you can't do that. But you're always going to discover when you multiply these type of binomials together, the two middle terms are going to add up to 0 or cancel out. So a quicker way to multiplying these together is just to square your first term. So square your first term, which is x. Square your last term, which is 2 in this case, and place a minus sign between them. That's it. So your product's going to be x squared minus what? Minus 4? And we're done. So x plus 2 times x minus 2 immediately give us a product of x squared minus 4. Does that make sense how we did that problem there? Okay, that makes sense.
I have
there?
a question.
Yeah, go ahead.
So you said the 2 is B. So like, would it be different if you had another number in the second set of parentheses, like you had a 3 right there?
Oh, but if we had a 3, if we had this scenario like x plus 3 times x plus 2 times x minus 3, these are not what? These are not conjugates of each other. So they're not conjugates. And because of that, you cannot use what? You cannot use this pattern. You see that?
Okay.
See, to be conjugates, the first terms have to be the same. And the last terms have to be what? The same. You see that? These are not conjugates because our last terms are not the same. So therefore we could not use this pattern to multiply these out. We would have to just multiply these out using our, regular FOIL method, correct? Yeah. We cannot use this special pattern to multiply these together because these are not conjugates. So they have to be conjugates, right? Where the first terms are the same, last terms are the same. The only difference is the sign between the terms. And if you got conjugates, then yeah, the product is going to be the difference between the square of the first term and the last term. But they have to be conjugates, okay? All right, so let's try another one here.
If the term is the same, can we use that pattern? Like
If what?
they're both addition, can we still use that pattern?
Oh, very good question. If they're both addition, can we use the pattern? What do you think?
I don't know.
No, no, absolutely not. You can't. Because to be conjugates of each other, the signs in between the terms have to be opposite. You see that? They have to be opposite. In fact, look at, if you had the same sign in between the terms, then we're back to what? We're back to what pattern then? Do you agree we're back to this pattern? If they have the same signs in between the terms, aren't we back to this?
Yes.
And we discovered that this would give us what? This, correct? Okay. So does that answer your question? In order to be conjugates, the signs have to be opposite here in between the terms. And yet the first terms have to be identical and the last terms have to be identical. That's the only time you can use this pattern. Anything different than this, it wouldn't work. All right. So they got to be conjugates. So let's see here, multiply. So if I got t plus 5 times t minus 5, are these conjugates?
Yes.
Okay.
Yes.
So therefore we can use our pattern. So therefore we just have to square our first term, square our last term, and place a what sign between them? What sign do I put between them?
Minus.
Always a minus sign. So therefore we have t squared minus 25. So t squared minus 25 would be the product of these conjugates. Right? 2x plus 7. I'm gonna take 2x plus 7, and it's sort of like I'm gonna take this 2x plus 7 and multiply it by 2x minus 7. Are these conjugates?
Yes.
That means I can get away with multiplying these together using the shortcut, square the first term, square the last term, and place a what sign between them? A minus sign, correct? So therefore, what's 2x squared? 2x times 2x. 4x squared minus what's 7 squared? 49. And we have, using the shortcut, just multiplied these conjugates together here. Let's take a look at this one here. Let's see, how about negative 2m plus 1 times 2m minus 1. Are these conjugates of each other? Are these?
No.
Okay, you're saying no. Why not? Why are these not conjugates?
One negative and one positive. The two.
Yeah, the first terms are not identical. You see that? This is a negative 2m, this is a positive 2m. Don't get me wrong, the signs in between the terms are correct, a positive and a negative. And the last terms are the same ones, but you're correct, these are not conjugates. Not conjugates. So you cannot use the shortcut on this one. You would have to actually FOIL this out the long way. Okay, they're not conjugates. What if I change it to negative 2m plus 1 times negative 2m minus 1? Are these now conjugates?
Yes.
Yeah.
These are conjugates now. The first terms are identical. The last terms are both identical. And we have a plus in between these terms, a minus in between these. Being the case, we can use the shortcut. All we have to do is square our first term, square our last term, and place a what? A minus sign in between them. Now, what's negative 2m squared?
Four square.
4m squared minus what's
Minus
1
one.
squared? Minus 1, correct? Yep, that would be the product of these conjugate binomials, just 4m squared minus 1. These are conjugates of each other. All right, so to be conjugates, the first and last terms have to be identical, and the sign in between the terms have to be opposites. If that's the case, you can use your rule. (12t squared minus 5p multiplied by 12t squared plus 5p. Are these conjugates of each other?
Yes.
Yes, they are. First terms are the same, last terms are the same, signs in between are opposites. Being the case, the product is going to be the square of the first term minus the square of the last term. Shortcut. In which case, this is going to be 12 squared. 12 times 12 is 144. T squared is t to the 2 times 2 power, t to the 4th power. 5 squared is 25, and p squared is p squared. There you go, ladies and gentlemen. That would be the product of these conjugate binomials here. Okay. They're just making sense here. How we're multiplying conjugate binomials. They have to be conjugates, though.
Yes.
All right, so we got that there. All right, they got to be conjugates of each other in order to take advantage of this this shortcut here. Well, they have to be conjugates, and if they are conjugates of each other, then you can use this special pattern or special product here. Okay. All right. Well, that brings us to classwork number 2, ladies and gentlemen. See if you can simplify all of these. All right, so let's see if we can try a couple out here. Problem number 1 we'll give you is going to be 5y to the 4th plus 8 times 5y to the 4th minus 8. Number 2, negative x squared y plus 6 times negative x squared y minus 6. Number 3, we'll have 7w to the 4th minus 3t squared times 7w to the 4th plus 3t squared. And number 4, Give you one more here. We're gonna have a squared minus 9b squared times a squared plus 9b squared. All right, so we'll try those out. Hold on a second. Try those out and see if you can multiply those together using a shortcut. Does anybody need more time on these? Somebody's asking if we have class next week. Well, let's see. November 24. Yeah, we are scheduled to, have class next week, ladies and gentlemen, on Monday and Wednesday. Now, I do post videos of the lecture, so, I mean, if you have to be somewhere, because, Wednesday night, some people have to be to the airport, but, or train station or bus station, whatever. But I will, post the video of the class session from next Wednesday evening, as I don't have to be to the airport myself. So I'll be on live. But yeah, nice thing is you get to see a video of the lecture. So that's not really a big thing. But yeah, I'm supposed to hold class Monday and Wednesday of next week. Yes, I am. All right. Well, how are we doing on these? Did anybody get the first one here? Multiplying these conjugates together. All you gotta do is square the first term. What's the square of 5y?
I got 25y to the 8th minus 64.
Yeah, we just have to square the terms and place a minus sign between them. So the square of 5y to the 4th is going to be 25y to the 8th minus 8 squared is 64, and that would be your answer. Okay. This one here, same thing. These are conjugates, so we would just square the first term minus square the second term. And so when we square the first term, a negative squared, when you square a negative, it's going to be a positive. And x squared is x to the 4th. Y squared. And it will be a minus and 36. That'd be your answer to the second problem there.
So it's not -1, it's just x.
For what now?
It's not, I got -1x to the 4th. So it's just x to the 4th minus.
Yeah, because you have a negative. When you square a negative, like if you got like negative x here and you square it, it's really like -1x times -1x, which means it's going to be a positive, 1x squared. You see that? So when you square a negative, you always get a positive. So when you square a negative, it becomes a positive, okay? So that will be a positive. All right. So that would be your answer to the second one, x to the 4th y squared minus 36. This one, these are conjugates of each other. So you square your first term minus, you square your last term. And 7w to the 4th squared is going to be 49w to the what? 4 times 2 power, w to the 8th. And when you square 3t squared, 3 squared is 9, and t squared is t to the 2 times 2 power, t to the 4th power. Did anybody get the third one correct?
Yes.
I did, yep.
This last one here, it is the product of, again, conjugate binomials, which means the product is going to be the square of the first term minus the square of the last term. And the square of a squared is going to be a to the 2 times 2 power, a to the 4th power, minus 9 squared is 81. B squared is b to the 2 times 2 power, b to the 4th power. And that would be the proper answer to number 4. Anybody got number 4 correct?
Yep.
Yes.
Yep.
All right.
Yeah.
Let me show you where this is interesting. I just seen this problem. This is where like the knowing that pattern can help you like multiply a couple numbers together. If you want to like multiply 49 and 51 together. Now, you could multiply this out the long way or even use a calculator, but I just think it's interesting that you could multiply this together more easily in your mind. if you think of 49 as being like 50 minus 1, do you agree? Times, and 51, you think of it as being like 50 plus 1. Does that make sense there? So I rewrote 49 like 50 minus 1, and I rewrote 51 as 50 plus 1. Now, what's the nice thing about this product now? These are what of each other? They are conjugates, aren't they?
Yes.
And so therefore, we would just square our first term minus the square of the last term. Look, we could do this in our minds. What's 50 squared? What's 5 times 5? 25. And you tack on 2 zeros. So 50 squared is 2,500 minus what's 1 squared? 1. Now what's 2,500 minus 1? That'd be 2,499. Ladies and gentlemen, we just multiplied 49 and 51 together a little bit more conveniently. Do you agree? That's pretty neat how that works, huh? I mean, just makes for an easier go of things if you think of this product as being this. Because like I said, you could probably do this, without a calculator or anything. You could probably, do this in your mind here. Let's see, 50 minus 1 times 50 plus 1 is 50 squared, which is 2,500 minus 1, 2,499. Do you agree? It's easier to do things using this method here as opposed to trying to multiply these together in your mind. You know what I'm saying? I just thought that was kind of cool. I just want to throw that out to you. Okay, now one last thing here that I want to draw your attention to, and this is on page 364 in your textbook. Tell you what, let me just go to that page on the computer. I think it'll be, well, let's see here. Maybe not. All right, what I'm going to do is I'm going to write this on a piece of paper here, because this will help us to understand the differences between what really look like the same things here. So we're going to kind of like split hairs on this one last thing in this section that we'll cover. All right, so I'm gonna make a little table here. If I got a number A and a number B here. Yeah, let's see here, down here. Okay, I will have A plus B squared here. I will have A squared plus B squared here. A squared plus 2AB plus B squared, and A plus AB, let's see, A squared plus AB plus B squared. And this, so it kind of looks like, all these things are saying the same thing, but are they? Do you think these are all saying the same thing? Now, two of these things are saying identically the same thing. Which ones are saying identically the same thing? Can you see it? Two of these rows are equal to each other. Which ones?
The third and fourth rows.
All right, the third and the fourth rows, you are correct. These are equivalent to each other, are they not? A plus B squared is really this, A squared plus 2AB plus B squared as one of our special patterns, was it not? Okay. All right, so suppose that we have some, let's see. All right, what if we have some numbers here? 1, 1, 3, 3, 4, and we got 1, 5, 4, 5. All right, how would I evaluate A plus B squared here? Well, I replace A with 1 and B with 1, correct? So A takes on the value of 1, B takes on the value of 1. And what's 1 plus 1?
Two.
And then 2 squared would be what? 4. Now down here, I replace A with 1, B with 1. What's 1 squared? That's 1. And 1 squared is 1. 1 plus 1 is what? 2. Now down here, we replace A with 1 and replace B with 1. A with 1, B with 1. 1 squared is 1. This is plus 2 times 1 times 1, which is 2. And this is plus 1 squared, or 1. This will be 1 plus 2, which is 3 plus 1 is what? 4. Do you agree that these are equivalent to each other? And they should be, because this is really equal to this. Isn't that true? This is this. All right, one last one. Replace A with 1 and B with 1. We get 1 squared, which is 1, plus 1 times 1 is 1. And 1 squared is 1. So this would be 1 plus 1 plus 1, which is what? 3. All right, let's just do maybe one more here. If A is replaced with
Whoa.
3, B is replaced with 5. We have 3 plus 5 is 8. 8 squared is 64. A is replaced with 3. 3 squared is 9. B is replaced with 5. 5 squared is 25. 9 plus 25 is 34. What do you think this one's going to give us when I replace A with 3, B with 5? What do you think?
64.
64. Yeah. Because, we already said that the second row, the third row is equal to this row down here, the fifth row. And one last one, replace A with 3 here. So you have 3 squared plus 3 times B is replaced with 5 plus 5 squared. It's going to be 9 plus 15 plus 25, which is going to net us with what? 49? 49. Okay. So you can see that these look similar to each other, but they're not the same. What we need to understand and remember that is that A plus B squared, ladies and gentlemen, is not equal to A squared plus B squared. I know it's tempting to say that, but it's not. Because we learned tonight that A plus B squared has a middle term to it, correct? It has a plus 2AB term to it. So just be careful with that. Be on guard with that. All right. Okay. So section 5.6, we learned, how many different patterns did we learn tonight?
Three
Main patterns. We learned 3 patterns tonight. Patterns, like I said, that would probably be wise to commit to memory. And these, ladies and gentlemen, are your 3 patterns that we learned tonight. Okay. Everybody see that there? 3 patterns. All right. So that's it. That's pretty much it for 5.6. Hopefully I'll see you on Wednesday, ladies and gentlemen. And after class on Wednesday, I will be giving you your chapter 5 quiz. You can work on that. I'll let you work on that for the rest of the week and probably turn it into me by the weekend. I'll specify the exact day. All right, if there's no other questions or comments or concerns, I'll let you go. You have a great night, and I'll stay on the line for a couple minutes if there's any issues. Okay?
Thank you. Good night.
Yep. Take care. Have a good
Night.
one. See you.